All right, let's walk through this example of how to find how many fish should be restocked each year to reach a given equilibrium level. So this is kind of the same setup that we've worked with a little bit already. Let's go ahead and just jot down that Rn is the number of years, and our X sub n is the fish population. So we know already that the 1,000 is our x0, so 0 equals 1,000, and then our x sub n plus 1, we have to think about two things. First, the annual growth rate, and also the fishing level. So for the growth rate, we do 1.5 x sub n. For the fishing level, we do minus 0.55 x sub n. And then we're asked to find how many fish should be restocked each year. So let's call that number R, and then we'll just write plus R. So that's the number of fish that we are just adding to the lake. Okay, so I'll just jot that down over here. R equals restocking level. All right, so again, this difference equation that we just wrote is not really written in the best way. We should combine our like terms. So we have x sub n plus 1. If we have 1.5 minus 0.55, that gives us 0.95 xn plus r. And then what we are ultimately trying to do is get to the equilibrium level of 4,000 fish. So remember, when we have that equilibrium level and we're trying to force our difference equation to achieve that equilibrium level, we're going to take that number 4,000 and plug it in for both xn plus 1 and x sub n. All right, so when we do that, we have 4,000 equals 0.95 times 4,000 plus r. All right, so that is the equation that we are trying to solve for r. So we grab our calculator and do 0.95 times 4,000, which is 3,800. So we have 4,000 equals 3,800 plus r. To get r by itself, we're going to subtract 3,800 from each side and get our restocking level to be 200 fish each year. All right, so the other part of the question up here asked us to write the new difference equation. I'm going to skip the graph because that is on the PDF already. But the new difference equation, basically we're going to take this value of 200 for r and plug it in this, plug it into this difference equation right here. So that gives us xn plus 1 equals 1.5 xn minus 0.55 xn plus 200, again, is our r value, or really we should have combined these terms. So we get x sub n plus 1 plus 0.595 xn plus 200. And that is our new difference equation that will reach the equilibrium level of 4,000 fish.